Hey guys, how you doing? It's Mr. Chavla. Let me sit up. I'm slouching again. I'm here to go over the final question in the June 2019 Common Core Algebra 2 exam. So this is number 37, our part 4 6-point question from the June 2019 Common Core Algebra 2 exam. So key number 37, that's our part 4, 6 points. All right, and again, it's Mr. Chavla or Mr. C. Let's jump right to it and let's get this back over with. I don't think it was that bad for a 6-point question for the final question on an Algebra 2 exam. Let's see what we got. Whoops, went too far. Okay, and I went over the other questions in the previous videos. Okay, so Griffin is riding his bike down the street in Churchville, New York at a constant speed. There we go. Got it? When a nail gets caught in one of the tires, the height of the nail above the ground in inches can be represented by the trig function f of t equals negative 13 cosine 0.8 pi t plus 13. So the f of t is the height of the nail above the ground in inches as it's stuck in the tire, right? So it's basically the height of that point on the tire where the nail got stuck. And t is the time in seconds since the nail got caught in the tire. Determine the period of f of t. So guys, a sine or a cosine graph, the general function looks like f of x or f of t equals the a times sine or cosine of b times t or x, whatever the input variable is, plus c. All we need to know right now is this b value. The b value is the coefficient of t, which is also known as the frequency. That's 0.8 pi. That's the first part. To get the period, the relationship is that the period times the frequency is equal to 2 pi. So the period times 0.8 pi or 0.8 pi is equal to 2 pi. Now what I'm going to do is I'm going to divide. I had it there already, but let me put it here. Show you guys. 2 pi divided by 0.8 pi is 2.5. Okay, so the period is 2.5 and it's time because it's the time it takes the graph to complete one full cycle. So the period is 2.5 seconds when I divide both sides by 0.8 pi. That's the time it takes the graph to complete one full cycle of the cosine curve. Is 2.5 seconds along the x-axis. And what does it represent in this context? It's just the time it takes the nail to return to the ground, like after the wheel makes or the tire makes one full rotation. All right, so the period is 2.5 seconds. What does it represent in the context? If I see the nail gets caught, the tire spins, makes a full rotation, boom, nail returns to the ground. So it's just the period is the time it takes the tire to make a full rotation or one full rotation. All right, that was it for, so the tire makes a full rotation. So interpret what the period represents in this context. The period is the time it takes the tire to make one full rotation, which is 2.5 seconds. Okay, now typically when we're graphing, so that's the next part, on the grid below graph at least one cycle of f of t. We'll just graph one cycle. We don't need to do more than that. So I put the grid in because I didn't want to waste my time me struggling with the ruler and everything, which I didn't even have one here. So I had to like just input the line, and I just and we have t over here. I like to move my lines in a little bit within the grid. If you put it on the edges, that's fine. But remember the period is 2.5 seconds. So we typically divide the period into 4 parts, and I'm going to minimize me for now, okay? We typically divide into 4 parts. I'm going to divide into 8 parts just so we could have a nice spread out graph, use some of the grid. You could have spread it into more. I don't know if I would want to do less. 1, 2, 3, 4, at least 4, okay? 5, 6, 7, 8. So 2.5, and then I'm just going to split into 8 parts. So here we have time in seconds, and on the y-axis we have f of t, the height in inches of the nail. Now, before we go to the graphing part, I want to do one other thing. Remember I talked about how we have f of t equals a cosine bt plus c? So I'm going to write the function again here. This question was asking, does the nail ever reach 30 inches above the ground? So if I have f of t equals negative 13 cosine of 0.8 pi t plus 13, I don't need the b value, the frequency, remember, was 0.8 pi. The a value is negative 13. Then the c value is called the midline, is positive 13. This is known as our midline. All right, that's the average height of the cosine curve. Now, to get the maximum height, well, before I even do that, guys, the absolute value of a is going to be positive 13, which by chance happened to be the same as the midline. Now, what we do, how do we use the midline and the amplitude? Well, to get the maximum height of the curve of the cosine, you add the, again, this is the amplitude. The maximum height, because they're saying, does the height ever reach, does the height of the nail ever reach 30 inches above the ground? The maximum is always the midline, C, plus the amplitude. That becomes 13 plus 13. Then the maximum is 26 inches. So the answer to the question is no. The maximum height is 26 inches. And we justified our answer right there. Now, to get the minimum, so we know the maximum, we justified our answer. Does the height of the nail ever reach 30 inches above the ground? No. Justify your answer, we just did. So we could do that without graphing. Now, remember I said the maximum, so we know the maximum is 26. 26 inches, and I'll just use this other symbol for inches, all right? The minimum, well, you know the minimum height is 0, but to get the minimum, if you do the midline, C, minus the amplitude, so it'll be, instead of C plus absolute value of A, it'll be C minus absolute value of A. This will change to 13 minus 13 is 0. So the minimum height is 0. So that helps us. The minimum height is 0 inches. And I'll even put F for max, F min. And the midline is 13. So our graph is basically going to fluctuate between 13, 0, and 26. So that'll help me get my scale on the y-axis. So this goes up by 20. So if I go up by 2 each time, so this is 2, but I'll skip writing that, 4, 6, 8. So I'll label every other one. Now I got 12, 16, 20, 24, and here's my max at 26. I'll label that one. All right, and now I'll fill in the middle. 6, 10, 14, 18. That's a little messy. You didn't have to label every single one. Now I'm going to go to the graphing calculator. Now when I graph it, I'm going to make sure I got this 1, 2, 3, 4, 5, 6, 7, 8. Now when I go to graph it, it'll be a lot easier. So I'm going to go to the graphing calculator. First thing I'm going to do is I'm going to make sure it's in radian mode. I could take a look at what the graph should look like, and I could also see what the, I could also use a table of values. So I'm going to make sure I'm in radian mode, which I am. Then the x-axis, remember we're not going to have anything negative. I'll put a little bit negative just so we could see. So remember we split the 2.5 into 8 parts. So I'll just go from negative 2. Let's just say negative 1. And the max will go up to its 2.5, all right? The scale, remember I said 2.5 over 8? The y-axis is not going to go below 0, but let's say I put negative 2. And the maximum height is 26, but I want to be able to see more, so I'll put 28. And I'll use a step of 2. Now what I'm going to do is I'm going to scroll back up, scroll to the left, and I'm just going to use the table for now. So I'm going to enter the equation f of x, or you could enter y equals, it was negative 13 cosine 0.8 pi x plus 13. And I'm just going to enter a table. So x, and you make sure you use the appropriate scale, right? You use the same scale that we used for the graph, which is that you're going to go up by 2.5 over 8 each time. I have to do it manually. You could do it by hand. I have to do the first one, so the initial height's 0. Now the first one, when I do it, the way I do it, when I push enter, the calculator is going to do it automatically. It knows that it's going to go by the same scale. And there you see the graph. It's going to actually plot the points as we go along. And once I'm up at 2.5, I could stop. So I want to see all these points. All right, I could use the graph, and I want to see the shape of the graph, what it should look like. Um, Sorry about that. I want to see what the shape of the graph should look like, and also I'm trying to get to, let's say, -6, so I could see everything now. So now I could use the table, but I could also get the points from here like this. So we got 0, 0 is the y-intercept. You see the shape of the graph? Now I want you to be able to see everything. So that's how we're going to shape our graph too. Now I'm going to go back to the table because it's hard to read from here. It's hard for me to fit everything in the screen. So I'm going to use the table now. All right, and I'm going to just enlarge this. We don't need the graph anymore. So these are all the points we need and we'll be good to go. So let's get that in and we'll be done with the question. So our y-intercept is 0, 0. I'll use blue to graph it. All right. I'm trying to make sure it all fits here and we could see the... Okay, so our y-intercept 0, 0, then we get about 3.8, which is right up here the next time. Then we get 13, which is halfway between 12 and 14. And then we get 22.2, which is basically barely over 22. This is why I labeled all the scales, guys, so that we can graph more easily. Then we go to 26, which is our maximum. And then we start coming back down to 22.2 again, same exact height. This is why it's like very cyclical. It follows like a very predictable pattern. This is one cycle. It's going to come back down. Then it's going to come back down to 13, the midline. All right, so remember it goes minimum, midline, maximum, then back down to the midline, and I got these little points in between. Then 3.8-ish again, and then it hits the ground. The nail returns to the ground, and our graph's going to look, if you remember from the calculator, something like this. It's not going to be perfect, guys, like in this scale with what they gave us. We just do the best we can, and we'll still get our full credit, all right? Because they understand there's no way to get this perfect. Well, but we could get it excellent. All right, and I want this to kind of look like that too. All right, and we just make sure we have our points labeled nice and clear. And there's no fuss about it, especially this one. And guys, that's actually it. That's our graph, okay? And we don't have to label this. I'll label 1, 2, 3, 4 halfway, or 1.25, but you don't have to do that. 1, 2, 3, 4, because remember, it hits its max height after 1.25 seconds, halfway through the cycle. All right, that's all we got, guys. That's all we need to do. So that was number 37. I'm gonna make the screen a little smaller so you could see everything. Okay, that's our graph. Isn't that thing a beauty? And they said to graph at least one cycle that includes the y-intercept, which it did. Okay, and then this was the other part. This was one of many ways to do this. We could have just said that the maximum height of the cosine curve is 26 inches, but I thought it'll be easier to get the minimum and maximum first before we go ahead and sketch the graph so that we know how to label our scales. Okay? And then we got our original part, 2.5 seconds the period, which helped us graph, and it's the time it takes the tire to make one full rotation. So as the tire goes from its minimum height through the midline at 13 up to the maximum 26, and back down until it hits the ground, until it reaches the ground. Again, the nail hits the ground at 2.5 seconds. All right, and I'll even label 0 and 0. All right, or I won't because it looks weird. Okay, that was it, guys. Let me come say goodbye. That was it for the the June 2019 exam. Yeah, I was like kind of getting comfortable there. Just okay. So guys, thanks for coming by. If you enjoyed the video, please hit like, subscribe. You got any questions? Let me know. Anything you want to bring to my attention, anything that you would like explained differently, let me know. Any comments, any feedback, I appreciate it very much. All right. Thanks so much and best of luck, guys. Bye for now.